FP3. This is FP3, June 2012, question 2. That question asks us to solve the equation z to the power 4 equals 2 lots of 1 plus I root 3, giving the roots exactly in the form r cos theta plus I sin theta, where r is greater than 0 and theta lies between 0 and 2 pi. And then it's going to ask us to sketch an Argand diagram to show the lines from the origin to the point representing 2 lots of 1 plus I root 3, and from the origin to the points would represent the roots of the equation in part I. Now, let's get started with this. So, FP3, June 12, question 2. Now, part I, z to the 4 equals 2 lots of 1 plus root 3i. Now, first, the easiest way to solve this is going to be to convert this into polar form, because, as we know, finding roots of polar complex numbers is much easier than finding them in Cartesian form like this. We have a quick sketch here of our complex number. Z to the 4 is represented at that point there, and that's our origin there. Now, what we know about this is that this is 2 along the base here, so that's 2 there, so the real part is 2, and the complex part is 2 root 3, so that's 2 root 3 up there. Not immediately obvious what this angle here is, but if you consider the similar triangle there, at that point 1 there, and root 3 there, this is a 1, 2, root 3 triangle, so we can see that in fact that pi by 3 is the angle in there, and so we know that the argument of z to the 4 is equal to pi by 3, and the modulus we can find by working out the distance from the origin out to z to the 4 there, which if we do a little bit of Pythagoras, you will find that the modulus of z to the 4 is going to be square root of 4 times 3, that's 2 squared times root 3 squared, plus 4 there, so is root 16, which is 4. So relatively easy to find the modulus there. So in fact we can now express z to the 4 as 4 lots of cos pi by 3 plus I sine pi by 3. And now it's going to be a bit easier to find its roots. Now, in order to find the root of a complex number, you have to find the root of the modulus, and then you're going to divide the argument by the power. So if I want the fourth root of this complex number here, I'm going to have to find the fourth root of 4 and divide pi by 3 by 4. So I can write down straight away that z equals root 2, because root 2 to the power 4 gets me 4, cos, now I want a quarter of pi by 3, so that's going to be pi by 12 plus I sine pi by 12. Now, as you know, there are in fact 4 roots of z to the 4 here, and so there are going to be 4 of these. They'll form a square, and 4 of them have to form a square, so we need to add on an amount to pi by 12 such that when we do that 4 times we come back to where we started. So we take 2 pi, divide it by 4, we're going to get pi by 2. So we achieve each new root by turning this pi by 2 radians. And so the next one, so z is also going to equal root 2. I'm going to add pi by 2 to pi by 12 and get cos 7 pi by 12. So this is the next root round in the Argand diagram. That's I sine 7 pi by 12. And it's also going to equal root 2 cos 13 pi by 12 plus I sine 13 pi by 12, so it's another one further round in our square, the next one round. So we've got the first point here, then the next one, and then the next one, adding pi by 2 each time, and then the last one is root 2 cos 19 pi by 12 plus I sine 19 pi by 12. Now, many people prefer to start to count these as negative angles round, but I've always preferred to work round them in 0 to 2 pi unless the question tells me otherwise. Now, part 2 of this question is asking us to sketch the Argand diagram to show the lines from the origin to the point representing 2 into 1 plus I root 3, from the origin to the points which represent the roots. So a proper sensible sketch to show what we've just done here. Now, if I'm going to get a ruler on this job and make life much easier for us. So a quick sketch of our Argand diagram. Now, out here we mark z to the 4 there, and that angle we calculated earlier is pi by 3 there, and that length we discovered was 4, so I've got z to the 4 at that point. Now my first root here is z equals root 2 cos pi by 12 I sine pi by 12, so I want root 2, which if that is 4 there, root 2 is about 1.4, so near enough. Something like this. So if that's z there, I'll give that a little index of 1, and then so that's z there, and that angle in there is pi by 12. Now the next one round is going to be at 7 pi by 12, so it's a little over half, so we estimate it out at about, well actually we can draw ourselves a better diagram by seeing what we actually measured, so about 2.5 centimetres out along there, so that point there, so that's my next Z2, and that angle all the way around there will be 7 pi by 12, and then we want another one. Now I know that these form a square because they're the fourth roots, so I know there will be another one like that, and another one like this, and these are my Z3 here and Z4 there, and they form a nice square. And if any of you have access to the MEI, excellent resources on from MEI, my square's not looking so good at the moment, there is a very useful tool on integralmaths.org where you can plug in a complex number and then make it find the roots and then play with the different positions of Z4, and you can see this change and take it up to fifth roots and so on. Extremely useful. integralmaths.org, this is. Right, and that is the end of that question. Thank you.